Example 10.8. A fully loaded Boeing aircraft has a mass of 3.3 into 10 raised to 5 kilogram. Its total wing area is 500 meters square. It is in level flight with a speed of 960 km per hour. A. Estimate the pressure difference between the lower and upper surfaces of the wings. B. Estimate the fractional increase in the speed of the air on the upper surface of the wing relative to the lower surface. The density of air that is given 1.2 in kilogram per meter cube. Okay. Now density that is 1.2 kilogram per meter cube. Now mass of the aircraft that is 3.3 into 10 raised to 5 kilogram. Area of the wings 500 meters square. Average velocity, or we can say speed of the flight, that is 960 kilometer per hour. If you convert it in meter per second, then it is 267 meter per second. Okay. Now see, when the level flight is there, it implies that the weight of the aircraft is balanced by the force exerted by the pressure difference. તો જ એ perfectly horizontal રહી શકે, right? So force exerted by the pressure difference, that is equal to weight of the aircraft. So pressure difference is suppose delta P into area of the wings, that is the force exerted by the pressure difference. So delta P into A, that is mg. So delta P, that is mg upon A. M 3.3 into 10 is to 5, G 9.8, area 500. Solve it, you will get pressure difference. Now if we apply Bernoulli's equation at 2 points, one that is in the lower part of the wing, another one that is at the upper part of the wing. Point 1, point 2, right? Like that. So if we apply Bernoulli's equation at the upper and lower part of the wing, we can write P1 plus half rho V1 square plus rho G H1. That is equal to P2 plus half rho V2 square plus rho G H2. H1, that is the height from the surface of the earth of this point 1, which is at lower part. H2, that is the height of the point which one is at upper part. But compared to height from the surface of the earth, thickness of the wing, it is negligible one. So we can consider H1 is nearly equal to H2. So rho G H1, rho G H2 cancelled. So we can write P1 minus P2, that is half rho into V2 square minus V1 square. P1 minus P2, that is pressure difference delta P. So that is equal to half rho V2 square minus V1 square. So we can write V2 square minus V1 square, that is equal to 2 delta P by rho. This one we can write V2 minus V1 into V2 plus V1, that is equal to 2 delta P by rho. So V2 minus V1, that is 2 delta P upon rho into this V2 plus V1. So we can rewrite this one as that is equal to delta P upon rho into V2 plus V1 by 2. Now this V2 plus V1 by 2, that is V average. So we can write V2 minus V1 equal to delta V. This is the change in velocity for upper and lower air layers. That is equal to delta P upon rho into V average. Now we want to calculate the fractional increase in the speed of the air. So fractional change, that is change in speed upon average speed. So here, to calculate the fractional change in velocity, multiply both the side by 1 upon V average. So on left hand side, we will get delta V upon V average, that is equal to delta P by rho V average was already there, and now it is multiplied by 1 upon V average, so V average square. Now delta P we already calculated 6.5 into 10 raised to 3, rho given to you 1.2, V average that is given to you 267 meter per second. Substitute it, solve it, you will get the fractional increase in the speed of air on the upper surface of the wing relative to the lower surface. Clear to all of you?